Hello and welcome to the lesson on build automation. In the previous lesson, we learned about the build process, which involved several commands to compile the source files and link various object files to generate an executable file. Then transform the executable file into flashable image and generate disassembled file to check code placement and debugging. Those commands are long and complex with several options to remember. It becomes inefficient to type the commands every time the project needs to be compiled. In this lesson, we shall learn about the build automation to simplify the build process and develop a make script which will form a base for build automation for complex projects going forward. Make is a utility for the purpose. It is the build automation tool that automatically builds executable program and libraries from the source code by reading file called makefile. The makefile specifies how to derive the target program. Make searches the current directory for the makefile and then runs the specified or default target. A makefile defines one or more rules to build the target. The rules must be written in a specific format. First, targets should be specified, then prerequisites separated by a colon. Then the next line describes the recipe. A target is usually the name of a file that is generated by a program. For example, executable files and object files. A target can also be the name of an action to carry out, such as clean. A prerequisite is a file that is used as an input to create the target. A target often depends on several files. A recipe is an action that make carries out. It may have more than one command, either on the same line or each on its own line. Please note, you need to put a tab character at the beginning of every recipe line. Usually, a recipe is in a rule with prerequisites and serves to create a target file if any of the prerequisites change. However, the rule that specifies a recipe for the target need not have a prerequisite. For example, the rule containing the delete command associated with the target clean does not have prerequisites. A rule then explains how and when to remake certain files which are targets for the particular rule. Make carries out the recipe on the prerequisites to create or update the target. A makefile may contain other text beside rules, but a simple makefile contains rules only. A variable is a name defined in a makefile to represent a string of text, called the variable's value. These values are substituted by explicit request into targets, prerequisites, recipes, and other parts of the makefile. Variables can represent list of file names, option to pass to compiler, programs to run, directories to look in for source files, directories to write output in, or anything else. A variable name may be sequence of characters not containing a colon, a hash character, a equal sign, or white space. Variable names are case sensitive. It is a traditional to use uppercase letters in variable names. Now, let's understand and develop make script, that is the makefile for the LED Blink program. I hope you already have the source archive downloaded and extracted. Create a text file in the Blink folder and name it makefile with capital M. When make command is invoked, it searches for makefile and executes the recipe defined in it. Let's start with adding the rules for compilation of blink.c and interrupt.c. Define the target, which is the name of the object file to be generated, that is blink.o. Then the prerequisite blink.c and the recipe, which is the command avr-gcc with options in the next line starting with a tab character. Similarly, add the rule for interrupt.o. These are called explicit rules as the name of the targets are explicitly mentioned. Launch the command line interface and invoke the command make. Make can be invoked in two ways. 1. Just the command make, and 2. Make followed by the target name. When the target is omitted, the make starts with executing the default target, which is the first target defined in the make file. So, when we run the command make, the rule to build blink.o is executed. The command make blink.o has also the same result. And the interrupt.o is built with command make interrupt.o. We need to execute two make commands to build the object files. This can be done in one single command. Define a target build, make it the first target in makefile, and add blink.o and interrupt.o as prerequisites. There is no recipe associated with the build target. With the new target, all the object files can be built in one command invocation. We have explicit rules for the generation of each object files. This is not a feasible way if we have dozens of C and assembly files. Define a new rule. This is called implicit rule and works based on the pattern matching. When the build target is triggered, make uses the implicit rule as no explicit rule is defined to build the prerequisites. The target %.o matches any target with non-empty file name and .o suffix. This one rule can build all the object files if the prerequisite of the build target lists all the object files. In the new recipe, you see some new terms, $less than and $at. These are automatic variables defined by make utility. The make replaces $less than with the first entity in the prerequisite list, and $at is replaced with the target. So, when the rule to build interrupt.o is executed, $less than is replaced by interrupt.c and $at with interrupt.o. Let's comment the explicit rules for blink.o and interrupt.o as these are no longer necessary. Use a hash character at the beginning of the line for commenting. Let's check if the newly added rule works as expected. Both the object files are generated successfully. Now let's add the rules to generate .elf, .hex and .asm files too, with corresponding dependencies. To build the ELF file, we have to use the command make blink.elf. This can be further simplified by defining target ELF with blink.elf as dependency. Similarly, Add the new targets for hex and ASM and change the prerequisite of build rule to ELF, hex and ASM. So, execution of make generates all the three files and the object files. There are times when the source directory must be cleaned of all the files generated in the build step. To achieve this, define a rule for this action with target clean and add the recipe to delete ELF, hex, ASM and .o files. Note, there is no prerequisite for this rule and clean is not a file name but just an action. Such target is defined as phony target. This avoids conflict with file of the same name and improves performance. The word blink is name of the project and is repeated several times in makefile. If this makefile is used for other project, the word blink needs to be replaced at different places, which opens possibility for introducing errors. To aggregate the change to one place, let's define a variable named target and initialize it with blink. In make script, variable is defined as shown but used a bit differently. The variable name is placed inside parentheses and prefixed with a $sign. Replace instances of blink with the newly defined variable target but not for the blink.o in prerequisite of ELF generation rule. Now, if we use the make script for different project, we just have to change the initialization of target variable. To complete the make script, add the rule to flash the microcontroller with prerequisite of hex file and command avr-dude with options as recipe. The target name for this rule is flash and must be defined as phony target. Now the command to flash the microcontroller is make flash. Let's execute the script to check if it is working as expected. As you can see, it successfully generates all the files, flashes the microcontroller, and cleans the source directory too. With make utility, we have greatly simplified the build process. With two concise commands, make and make flash, the entire build process can be executed and the microcontroller can be flashed. There are few more improvements to be made to the make script for portability across development platform, microcontroller, and projects. We shall implement those in the next lesson. With this, we conclude the lesson. I hope it was an interesting session. Have a great day.